Good morning, good morning, good morning, good morning, everybody. Hello, 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 hello. Welcome, everyone, to office hours for unit number 1, World Quant University's course in data science. I'm so excited you guys are here. We are ready to roll, we're ready to rock, we're ready to rumble. We're going to do some data science today. How is everybody doing? I already see some familiar faces here in the chat. I see Aman is here, Jeffrey, Andrea, Mateen, Kingsley, Ben is here, Tanfan is here. Wonderful, wonderful, wonderful. So glad to see all of you here. How's it going? I see Tiger is here, Henry is also here. Excellent. Mumenya is here. Kingsley says this course is getting more and more interesting. I am so glad to hear that. That is just fantastic. Ben wants to know how I'm doing today. You know, I'm doing great. Thank you so much for asking. Everything is fantastic. So I'm very happy to be here, very happy to be with you guys. Andrea says they've applied already to Module 2. Don't worry about the date confusion. We'll deal with that later. Don't worry. The important thing is you applied. I see Julius is here from Kenya. That's great. I'm so glad you're here, Julius. And Kevin is also here from Kenya. So we have the Kenyans are well represented, which makes me very happy to hear. So what are we going to be doing today? Well, I know that one thing we're going to be doing is pandas because I promised we would do pandas today. And honestly, I think that we could spend all of today, working on pandas. So that's definitely a possibility. Is there anything else that people would like to talk about? I see Fet is here. Hello, Fet. Good to see you again. Everyone, Fet is an alum, a graduate of the course from what, 2, 3 cohorts back? So welcome, welcome. And Fet wants the data for the PW and DW. I don't think we can give you that data because it has to do with the mini projects. So I can't just give out all the data for the mini projects. That would give everyone the answers. But if you're interested, Fet, if you go to your notebooks, you can see that there's some wget. You should be able to get them from our Amazon storage bucket. And Emil wants to know, how can they apply to Unit 2 even if they haven't finished all of the mini projects today uh, or yet? And the answer is just apply. As soon as you complete the mini projects, you'll be automatically enrolled into Unit 2. Andrea wants to know if I'm going to share my notebook today. Absolutely, I am. So the first thing I'm going to do is let's just jump into pandas. Let's do it. So I'm going to open up data cores, and then I'm going to create a new Python notebook, and I will rename it. I'll rename it DS Office Hours for the 30th. And today we're going to be dealing with our dear friend pandas. So let's do that. Let me put a title in here. And, Saud is asking which data science libraries are important and which one should we focus on? I would say pandas is one of the most important, ones. So today we're going to dedicate a whole day to answering your questions about pandas. So the first thing that I'm going to do is I'm going to import pandas as PD. And then the other thing I'm going to do in case we have to do some visualization is I'm going to import matplotlib.pyplot as PLT. And then the last thing I'm going to import is from sklearn.datasets. And sklearn is a machine learning library, but it also has a lot of data sets in it. And so I'm just going to grab one of those data sets so that we can play with it here today. So from sklearn.datasets, import fetch California housing. And for people who are interested in learning more about the California housing dataset, there's a great little description on Google, which I will paste. And then what I'm going to do is I'm going to add a link here. And I'll just say, today we're working with the California housing data set, which you can import using scikit-learn. All right, beautiful. So first things first, I'm going to import the data set as it's given to us from scikit-learn. Don't worry too much about this part. This is just me getting things set. So I'm going to create a data frame and then we'll jump into pandas. Now, the first thing that I'm going to do is I'm going to instantiate a variable called data, and it's going to be just running the fetch California housing method. And it's going to say that it's going to be downloading it. And once that's done, there are a bunch of things here in this data set, in this data, it's called a data bundle. There's both the data itself, there are the column headers, there's a description. In fact, if I go to print data.descr for description, this is going to give us the whole description of what's in the data set. So this data I'll know comes from the 1990 US Census. And during the census, they divide the state of California up into these little geographical blocks. And the information is for each block. So I have the median income for each block, the house age, the median house age for each block, et cetera, et cetera, et cetera. The latitude and longitude, all of those good things. So next I'm going to create my data frame. So I'm going to instantiate a data frame called DF. And oftentimes when you first import your data into pandas, into a pandas data frame, you just use DF as an abbreviation. So what I'm going to do is I'm going to do PD and then data frame. And the first thing I'm going to do is I'm going to pass in the data. So I'll pass in data.data. So this is just the actual array with all of the data. And then the next thing I'm going to do is columns. I'm going to say it's going to be data and feature names. Okay, beautiful. So now I have my data frame set. If I want to start, all right, I'm going to start doing some exploratory data analysis. Some exploratory data analysis. What are some commands that you guys suggest that I use in order to do exploratory data analysis? What have we seen in Dylan's videos or in the videos for this week and last week that would be helpful for getting an understanding of these data? So Subham says I should start with head. So I will. I'll start with head. And what head is going to give us is it's going to give us the first 5 rows of the data frame. I love all of these. Thank you so much. And if I want more than 5 rows, I can actually change, I can pass in an argument, just pass in an integer here, and it'll give me more if I want the first 10 rows, for example. Or if I want the last 10 rows, I can also use tail, as Tatanka is suggesting. But for now, I'll just stick with head. All right. Now, another one that Tatanka is suggesting is also shape. So I'll do df shape. Andrea suggested that too. And here I can see that I have 20,640 rows and 8 columns. Often data sciences, they don't say rows and columns, they say 20,640 observations with 8 features. I mean, we can say rows and columns too, but often we say observations and features. Beautiful. Another one that someone has suggested is describe. So I'll do df describe. And let's see what I get there. Thank you guys for all of these suggestions. Well, here I have each of the columns. And in each of the columns, I have the count, I have the mean, the standard deviation, the minimum and maximum, and also the quantiles. The quantiles. So that's going to give me some interesting information in terms of, it's going to tell me about the different, the characteristics of the different features in this data set. For example, I can see that median income here is 3.8 and house age is 28. So I know these really aren't on the same scale. Here's a question though. Here it says median income is 3.8. What do you guys think that means? Do you think that means that people in that census block make $3.87? I'm sorry, I meant the mean, the mean. Do you think the mean income is $3.87? I suspect that there's some parts of the world where that makes sense, but in California, it's very hard to have an income of $3.87 every year. So let's keep that in mind. Some other things that you guys have um, suggested. I can use, Margaret suggested D types. And if I look at D types, I have all of the column names and I can see that they're all floats, which confirms what I'm seeing here with my visual check. It seems that these are all floating point numbers. Saud says maybe $3.87 makes sense in 1880. That's true, but I know that this data comes from 1990. And there's one other one which I want to suggest that everyone use. Usually the big two that I always use are head, and then the other one is DF info. DF info, which gives me all sorts of useful information. The first is it tells me what the index is, which we'll get to in a second. And we have the number of entries. We have the number of columns, 8 columns. We have the number of entries in each column, which in this case, this is a complete data set. There are no missing values. And I also get the data type for each column. So this is all useful information. Between head and info, I have a lot of useful information. Now, Franklin says, is it also possible to say observations for the rows and variables for the columns? Sure, absolutely, no problem. But in data science, we just tend to say observations and features. But, it's like 6 one way, half a dozen the other. It doesn't make a lot of difference. Beautiful. So Paul has made a really interesting discovery. If we scroll up here to the description, we see we have median income, but if we also go to the website here where we have this information, we can see that median income is measured in tens of thousands of dollars. Beautiful. So already we're getting to have some understanding here of what's in our data set. Beautiful. Okay, so let's look again at df head. So here I have the column headers, I have the first 5 rows, and then next to each row, I have a number. And this numbers, or this series of numbers here, is called the index. In fact, if I type in df index, it's actually going to give me a long, let me see here. If I type in df index, it's going to give me, there we go. It's going to give me the index, and it says it starts at 0 and it stops at 20,640, and it goes up by 1. And this index is very important because what it allows me to do is it allows me to access slices of the data. So if I want to access a certain row, I can do df loc, and then I can put in the label. In this case, and it will give me one of the rows. It'll give me one of the rows. Now, what if I want to access a column? How can I access a column? So Raj says series. Absolutely, that's where we're going. But how can I access a column? What if, for example, I want to access the median income column? Saud says I can access it by name, and that's absolutely right. I can do df and then my square braces, and then I can put in the label for that column as a string. And I'm actually just going to look at the head of that column. And here we can see that I have the first 5 rows, which correspond to what we see in the head originally. So I have this information here, and this is my series. And the series has a couple parts to it. The first is it has the index. So it has the same index that operates throughout the entire data frame. So that's the first thing. So no matter if I pull apart all of these columns into separate series, they'll still all share the same index. And then the other thing that I have are the values for each row in our series. And then lastly, I have some metadata information. I have the name of the series, and I also have the data type for that series. And I can put anything in here. I could put house age, I could put whatever I wanted. And let's step back for a second. We talked about how we can access a column by using the column label. And we talked about how we can access a row by using loc. And how can we deal with that? Now, here's my question for you guys. Here I have this printout of information of the row. What is the data type here? What is the data type of this output? And loc stands for location. So when I do df.loc 0, I'm saying give me the row with the label 0. And what's returned to me, Anise says it's an array. What do other people think? Is this an array? If we look at the bottom, well, it's definitely an object, but what kind of object is? If I look at the bottom, it gives me the name and it gives me the data type. Here I have labels and here I have values. And so Kingsley and Saud are right. This is a series. So if I look at type, it's a series where the labels are the columns, or what was originally the columns, and the values are the values in that row. So just keep in mind that when you use loc and you get an entire row, it returns a series to you. And within that series, we can see that all of the values in the series are float 64. Now, Jay wants to know how a series is different. Excellent. Kingsley also wants to know what happens when we access a single column, like we've done here. Whoops, like we've done here. Let's look and see what the type is. It's also a series. So we could say that, generally speaking, a data frame has rows and columns. And if I want to access just a column, each of the columns is actually a whole series. So if I want to access the column, I just get it using the square bracket notation. And if I want the row, I can use the .loc command. I don't know why I'm drawing this all out with my fingers. I can use the .loc command, and that will return the row, but it actually, the data type it returns is a series. And that's important because it has to do with how you access the different parts of it. Now, a series, what makes a series different from other data objects? Well, it has a name on the one hand, and also a series. All of the values in a series have to be the same data type. And I see a question from Franklin. How do I access not just a single column or a single row? How do I access a single value? Well, there are a couple ways to do that. The first is I can use dfloc, and then I would give it the index label and the column label. And that would give me a single value. And if I look at the type, it's going to be a float, which is fine. So I can use loc. And let's be clear here, guys. When I refer to a series, I'm talking about a data type that exists in pandas. I'm not talking about time series data, that is to say, data that was taken at certain time increments, like a temperature reading every minute or every hour. It's just called a series. So it's not quite the strict statistical definition of series. It just means a data object that has row It has an index, it has values, and those values are all the same data type, and it has a name. Now, there's one other way to access values in a data frame, and that's using not loc for location, but iloc for integer location. And for integer location, I don't use row index labels and I don't use column labels. I use kind of coordinates the way that I would in a NumPy array. And so if I wanted the 0th row, I would do 0, not the label, but the number. And if I wanted the first value, the first column, I would do column 0. And that would give me my 8.32, which we see right here. And if I wanted multiple rows, I would use the colon. For example, this would give me the first 4 rows. So this gives me the first 4 values of the first column. And if I wanted to take like a rectangular slice, I could take the first 4 rows of the first 4 columns, which would look something like this. Or I could take well, let's take the second 4 rows. Oh, whoops, I did an extra one there. And so that's how I slice my data. Now, this is super important, guys. There's one little difference between loc and iloc that is very, very important. If I do loc and I give the labels 0 through 4, and then I do median income, whoops, I misspelled that, median income to AV, what is it? Average rooms, it's going to be inclusive. So I'm going to have the 0th row, but I'm also going to have the 4 row. So I'm including, if it's up here, it's going to be inclusive. I have rows 0 through 4 with those labels, and I also have columns, median income, up to and including average rooms, so 3. However, if I do the same thing with iloc, and I'll do 0, 4, and in this case, since average bedrooms is the third column, I think I would do 3 here. It was average bedroom is 0, 1, 2, excuse me, 2. Now if I use iloc, it's a little bit different because if I have, you'll notice that I don't have the first 5 rows. I don't have indexes 0 through 4. I have 0 up to, but excluding 4. So it's the 0 is inclusive and the 4 is exclusive. So I don't include the 4. And the same thing with the columns. I have column 0, I have column 1, up to, but not including column 2. So here the 2 is exclusive. So when you use loc, it's inclusive on both the start and the stop. And when it is iloc, it is inclusive on the start, but exclusive on the stop. So here I'll put inclusive, inclusive, and here I'll put inclusive, exclusive. Okay, beautiful. I love this. Okay, now, before we get into conditions, I want to do just a little bit of other things. I want to do a few other things. The first thing that I want to do is I want to talk about how you can easily do operations on these data using the tools that Pandas has created for you. So, for example, we've already discussed here that this median income, this is 7.1 or 8.3 or whatever, these are in tens of thousands of dollars. And so maybe what I want to do is I actually want to have this be in tens of thousands of dollars. So let's see how we might do that. Well, I'm going to create a new column, and I'm just going to call it median income. And I'm going to say, take the column DF median income and multiply it by 10,000. And then if I look at the head, I'll see that I now have a new column where it is tens of thousands of dollars. And, you know, when we're thinking about one of the great things about NumPy and Pandas is that you can perform these operations. You don't need a for loop to go through every row. You just say, create this new row, and voila, it appears, and it's quick. And Suraj wants to know why I put an underscore between median and income. It just makes it a little bit, oh, wait, here, why the underscore for 10,000? It actually doesn't matter. I could write it like this, or I can put an underscore in just so it's easier for me to see that it's 10,000. In American notation, sometimes we put a comma here. That doesn't work. Or a period, I think in British notation. But in Python, you can use a underscore, and it will ignore the underscore and just give you the number. And so if what I want to do is I want to create a new column called median income, where it's the median inc column times 10,000. And I don't need the underscore here, but it's just for readability. And voila, there's no for loop, but now I have my median income right here. And the great thing, another great thing about pandas, because up until now we've been doing some exploratory data analysis. Saud wants to know if we can change the position. Actually, if you create a new data frame, you can pass in the order you want everything to be in, but you can't swap things around and like drag them like you might do in Excel. And the reason is because generally speaking, for pandas is for data frames that are so big, you're never really going to see all of them at once. And Anita, I see your question. I will get to it in a second because that's the next thing I'm going to talk about. But first, I want to talk about one other thing. We've been doing a lot of checking of the numbers, but maybe doing some quick plots would help us understand this data a little bit better. And one of the things that Pandas does is it not only gives you some of the tools that we have with NumPy, but it also gives you some simple tools that we can get from matplotlib to do some quick visualizations. For instance, let's say that I want to look at the median income. And what I'm going to do is I'm going to plot it. And I want the kind of graph to be a histogram. And Yahia says, in R, they use a $sign to access the column. To access a column for a data frame, you either use this bracket notation, which we've been using, or you can use the dot and then median income, the column name. So those are the two ways to access the column. And in fact, that's the reason that I used an underscore in the space between median and income. So that way, if I wanted to access it using this syntax, I could. So here I have, and let's clean this up a little bit. I'll do PLT X label. Median income in dollars or USD. Voila. And so here I can see the distribution of income in median incomes across the different census blocks. So it's a little bit different from R notation, but it's basically the same thing. And Saud says this seems a little dull, but actually the point here is not to create a final version, but rather to do a quick visual check when you're doing your exploratory data analysis. And if you want to do something more complicated later on, go for it. But for now, we're just going to keep it simple. No problem. And the reason that these bars are connected is because this is called a histogram. And this is the way that histograms look because they're trying to show the distribution of the data. So whenever you want to show the distribution, that's the way to do it. And it's absolutely right. We're assuming that the data are continuous here. There are other ways for us to look at the data. I could look at the whole data frame. Let's see here, DF, I'm going to, actually that won't look very good. The other thing that I could do is I could look at, let's see here, let's look at average bedrooms and average rooms. So I'm interested in looking at these two. So I'm going to go DF, and let's say I want to access two columns at the same time. In that case, I would use my square brackets, and then I would add a separate set of square brackets, and then I would pass in the columns as a list. So I'm passing in the columns that I'm interested in as a list. So if I look at the head here, you can see that I have this little mini data frame, this slice. And then what I'm going to do is I'm going to use the data frame, another great thing that comes with pandas, something called the box plot. And if I look at the, oh goodness gracious, this is pretty, there's definitely some outliers here. So if I look at, let's see here, if I look at average bedrooms, this is interesting. So here we can see that we have an issue where, let's look at average bedrooms again. I'm going to go to DF, DF describe. And if I look at average bedrooms, I can see that the average is 5, but the maximum is 141. I don't know who has 141 rooms in their house. I hope they're small rooms. But obviously, this isn't going to work if I want to be able to look at the data here. So let's think about how we can fix this. So let's start from 0 again. I'm going to create a new data frame, and I'm going to call it bedrooms. And then I'm going to say it's just the two columns from the original data frame, the average rooms and the average bedrooms. So maybe what I'll actually do is I'll call it rooms, rooms. And I'll look at rooms.head. Beautiful. I could use a log transformation. Actually, that's not a bad idea. But another thing that I could do is, let's say that I want to exclude all houses that have more than, say, 15 rooms. How can I do that? Well, what I can do is I can say rooms, which is the name of my data frame, and then AVE rooms is less than 15. And if I look at the head of this, maybe they're hotels. Sure, I don't know. I can put in this sort of conditional. And what if I look at what it returns to me is a series. This is a series. It has a name. It has index labels. It has values. And these values are either true or false. And so it's a Boolean. It's a Boolean. This is a Boolean series. And what I can do is I can save this. I'm going to save this as a mask. This is what we call a mask in pandas talk. And once I have my mask, I can say, show me rooms, but I can mask it. I can say, show me only the rooms, the rows in the rooms data frame that meet the criteria for the mask. And so if I do that, if I look at the original rooms and I look at the shape, I can see that there are 20,000 rows. If I look at the rooms with the mask and I look at the shape, I can see all of a sudden we've dropped about 109 houses, which we can consider outliers. Honestly, let's make it 10. I feel like if you have more than 10 rooms, you don't have a house, you have a castle. So I'll go from 2,640 to 20,413. And now that I have my reduced data frame, I can do my box plots. And all of a sudden, I have a much clearer idea of the distribution. Actually, let's even make this, let's say less than, let's say 8 is our cutoff. There we go. And so here in this box plot, what I can see is the green line in the middle is the mean, the average. The box signifies the 25th percentile and the 75th percentile. And the whiskers here, the lines that come off, those are the minimums and maximums. And then these dots that are at the end are outliers. And in fact, I could make even a more complicated box plot, or a more complicated mask, I should say, by having this as one filter, and then using the ampersand symbol for and, adding another set of parentheses, and putting here more than two. So more than 2 rooms, but less than 8. And Suraj makes a really good point. Why do we not use the Python and here? The problem is that, well, not the problem. Pandas uses a slightly different notation. So when you're creating these masks, you have to use the ampersand for and, or if you want to use or, you use the vertical bar. And there are definitely different ways to do this in SQL or CSUN or other stata R, whatever. This just happens to be the notation. I see Athar has a technical problem. Athar, you should write an email to the support team, and that way they can troubleshoot it. So the double pipe actually doesn't work here. This will throw an error, but the single pipe works here. This would be basically everything, because everything is between these two. And so this is how so what have we done today? Let's do a little bit of a review. I'm going to scroll up here, so everyone hold on to your seats. Don't get motion sick. So the first thing that we did is we downloaded the California housing data set. We imported the data frame and we did some preliminary data exploration just by looking at head, looking at the shape, asking to describe each of the columns, and also looking at the data types, and also very important, info. Probably the two most important for me are head and info. And then we looked at how we could do locations. We could pull out sections of the data. So we looked at how we could pull out columns and how each column is a series. It's called a series in pandas. We looked at how the series all have these index labels along with their values, and how a series needs to be a single data type. We also looked at how you can pull out a single row using the loc command, and how that also actually returns a series. And then we looked at pulling out whole chunks of the data frame using the loc command, and then also using the iloc command. And remember that there's that little issue of inclusive for loc and inclusive exclusive for iloc. After that, we looked at how you could do some mathematical operations to create new features in the data set or new columns. In this case, we took the median income column and multiplied it by 10,000. Then we looked at how you could do some preliminary visualizations. We looked at a histogram for plotting the continuous values of median income, the distribution of median income across the data set. And then we also created some box plots. And when we created our box plot, we realized that there were a lot of outliers here. And so what we did is we created a mask where we limited the data that we were looking at so that we could get a better picture of the data. And how you can use a mask with not just a single criteria, but multiple criteria. And then we created a new box plot. So what I'm going to do is I'm going to download this to my local machine. And then I'm going to go to Jupyter Hub. And Tiger is right. A mask is a filter. It's a fancy way of saying filter. And I'll go to Video Downloads. And then I'm going to open up Google Drive. I'm going to drop in the office hours here. And that way, if you're interested in seeing what we did today, you can go to the video downloads, and here are the office hours for today. So you can download this and you can do everything we did locally on your machine, or you can upload this notebook to your server and it will allow you to run it there. Okay, it looks like we are done. We're even 2 minutes over, but I just want to say thank you guys. I can't wait to do more pandas and other stuff for you tomorrow. And until we meet again, happy data science. Bye bye, everyone. Take care.